In the development of business application software, relevant aspects of the real world must be represented in data form. A business unit represents an entity. These entities exist in relationships with each other, which are fixed in the underlying data model, also referred to as the Structured Entity Relationship Model, SERM. You use this data model as the basis for implementing appropriate table definitions, that is, transparent tables, including their relationships with each other in the ABAP dictionary. By activating table definitions, corresponding database tables are automatically created in the database. The actual application data is entered into those tables later on.
Customers of a travel agency who want to travel from one place to another by air want to obtain the following specific information from the travel agency. Required information: which connection offers the best and most direct flight? What are the acceptable flight times on the proposed days of travel? Which connections offer the cheapest flights, the fastest connections, and connections with target arrival times? On the other hand, the travel agency has different requirements. In the data model designed for managing the required data, the data is stored according to the technical criteria in tables in a central database. The amount of the stored data exceeds that needed to respond to the requests of the customer. You therefore need to be able to compile the data needed to satisfy the requests of the customer using application programs.
The flight data model contains the following entities for all business information that is logically connected: cities, airports, airlines, flight routes, flights. These entities relate to each other in the following ways. Each flight schedule contains one airline, one departure airport, and one destination airport. Each bookable flight belongs to one existing flight schedule. Each assignment can be set between the relevant cities and the nearby airports. You can manage all of the necessary data without redundancy by using these relationships. At the same time, the travel agency is able to obtain all of the data requested by the customer.
For each entity fixed in the data model, the developer creates a transparent table in the ABAP dictionary. This is a platform-independent description of the database table and not the actual database table. However, when the transparent table is activated, the system creates a table of the same name in the database. A transparent table contains various fields, that is, columns, that allow you to store and manage data records in a structured way. Table fields are declared as key fields when the content is to be used for the unique identification of data records within the database table. The key of a table, that is table key, consists of key fields. This is also called a primary key. Data records in the same table must be unique with regard to primary key values. The key value of a data record thus has a unique ID within the table.
In the ABAP dictionary, a transparent table is implemented using a description of the corresponding database table that contains the actual data used by the application. The fields of the transparent table form columns in the corresponding database table with identical names. Data elements, which you already know as globally defined elementary data types, are normally used for describing individual fields. Data elements refer to domains for their technical properties.
In addition to the list of fields, transparent tables contain other information that the system requires to create a table of the same name in the database and to describe the complete properties of the table. Transparent tables contain the following information: determination of the key for the database table, that is, key fields; technical properties required by the database to create the database table, such as expected size and expected frequency of access; Settings for technologies that can speed up access to the database table, such as secondary indexes and buffering.
The definition of a transparent table appears to be very similar to the definition of a global structure type. Transparent tables can be used in the same way as structure types in programming. For example, transparent tables can be used for defining a structured data object such as structure variable, for typing an interface parameter, or as the line type of a global or a local cable type. Only the list of fields is important. Other properties of the transparent table, such as the key definition or the technical properties, are irrelevant when it is being used as a data type. A transparent table is a list of elementary fields, whereas the components of a structure type can themselves be structured again as nested structures. The components of a structure can even be typed with the table type as deep structures. Structured Query Language, or SQL, is a language that enables users to define, change, and have read access to database tables. Every relational database system has a native SQL that is specific to the database. Therefore, an ABAP program with native SQL statements cannot be used without restrictions in all other SAP systems due to differences in database systems of various SAP systems. In contrast, OpenSQL is an SAP-defined, database-independent SQL standard used in the ABAP language. The system dynamically converts OpenSQL statements to native SQL statements of the target database system, and as such, OpenSQL statements remain independent of the database. OpenSQL allows the ABAP programmer uniform access to data regardless of the installed database system.
You can also execute a free search using the Repository Information System. Before you program direct accesses to database tables, look for reuse components that take care of the read process. The figure gives an overview of those read routines that SAP supplies, which you can use in your program.
Types of reuse components that encapsulate database accesses are as follows. Logical databases. Logical databases are data retrieval programs that read data from tables that belong together hierarchically. Function modules. Function modules are procedures stored in the function library of the SAP system with encapsulated functions, such as reading from hierarchically related tables. Business Application Programming Interfaces, BAPIs. Examples of BAPIs include methods of business objects with read functions, methods of global classes. If there are no usable reuse components available for your data selection, implement the read access using the following methods. Encapsulate the access into a reuse component. In other words, create function modules or methods of global classes.
Use the OpenSQL statement select to program database read access. The select statement contains a series of clauses, each of which has a different task as follows. The select clause names the fields of the table that are to be read. The from clause names the source, that is, database table or view from which data is to be selected. The into clause determines the target variable into which the selected data is to be placed. The where clause specifies the columns of the table that are to be selected. For information about other clauses, refer to the keyword documentation for the select statement. The select single statement allows you to read a single record from the database table. To ensure unique access, fill in all key fields of the where clause. The client field is an exception. If nothing is specified, the current client is assumed. A client can only be specified in the select statement in combination with the client-specified addition. Use an asterisk to specify that all selected fields of the table row are to be read. If you only want a specific selection of columns, replace the asterisk with a list of required fields as shown in the figure. Use the into clause to specify the target variable to which the data record is to be copied. Target structure has to be left justified in the same way as the field list. If the system finds a suitable record, SY sub RC returns the value of 0.
If you only want a certain selection of fields from the table row to be read, specify these as shown in the field list within the select statement as shown in the figure. Then, name a target structure variable in the into clause that has the same structure as the field list, at least in the beginning. In other words, it contains the names of the fields that are in the field list and in the same order. Only the corresponding field types have to match. The names of the target structure fields are not taken into account. Alternatively, list the corresponding target fields in the into clause as follows: into field 1 to field n.
If you want to use a structure variable for receiving the read record, which has fields with the same names as the fields in the target list, but has a different structure, like additional fields or different order of fields, use the corresponding fields of addition. This has the effect that the system only fills the fields with the same name as in the target area. Make sure that the field types are also the same for corresponding fields. Otherwise, as in the move statement, a complicated conversion starts, and it is possible that only incomplete data caused by cutoffs will be transported to the target fields. The advantages of using the corresponding fields of structure variable are as follows. The target structure does not have to be left justified in the same way as the field list. The construction is easy to maintain because extending the field list or target structure does not require other changes to be made to the program, as long as there is a field in the structure that has the same name and, if possible, also the same type.
You can use the select loop to read several rows of a database table into the program in succession. The where clause determines which lines are read into the target structure and processed using the statement block specified in the loop body. You can logically connect multiple logical conditions within the where clause using AND or OR. The database delivers the data to the database interface of the application server in packages. The processing block that you specify copies the records to the target area row by row for processing. The loop is left automatically after all of the required rows have been read and evaluated. You should query the return value after the select loop, that is, after the end select statement. The SY sub RC returns a value of 0 if the system reads at least one row. In this case, SYDB count contains the number of records read.
An array fetch is not a type of loop processing, so no end select statement is required or allowed. In the same way as the select variance, the internal table that is specified as the target in the array fetch must be structured with left justification, just like the field list. If the internal table does not meet this prerequisite, you have to use the into corresponding fields of table addition instead of the into table addition. There, the database columns specified in the field list are copied to the columns of the internal table that have the same names. Make sure that the field types of the corresponding columns match in order to avoid complex conversions and possibly incomplete data transfer to the target table. With array fetch, any content that might be present in the internal table is overwritten. If you want to append rows instead of overwriting, use the appending table addition. If the system copies at least one record to the internal table, sy sub rc returns the value of 0. The number of rows that were copied is recorded in sydb count.
A database table is classified as a client-specific table if it has a client field or data type CLNT as the first key column and contains client-specific entries. If you select data from a client-specific table without specifying the client, only data records from the current client are read. The current client data is transferred to the database system from which the data retrieval was initiated. If you want to read data from an explicitly specified client, specify the client name in the where clause. However, the client-specified addition must be made after the from clause. As cross-client reading is rarely requested in practice and is not relevant in the context of this course, the client field is usually omitted in presentations.
OpenSQL has a range of technologies available to enable you to optimize the runtime requirement.
Every database manages the data records within the database table based on key fields. If access to the table is restricted to all or at least the first few key fields, the database can quickly and effectively access the required data records. If database access is directed at fields that do not belong to the table key or non-key fields, the internal ordering principle cannot be used for rapid access. In the worst-case scenario, the entire table, or at least a very large part of the table, has to be searched for the required entries. This is referred to as a sequential search, and the wait time for the next database access can be very long. Note, in the figure, the data records within the database table are sorted according to the key field and stored on this basis. Some database systems actually work in this way. With others, the data records are not sorted. Instead, an index is created using the key fields. This index is referred to as the primary index. This is of no significance here.
If you access a database table frequently using a certain selection of search parameters, defining a secondary index containing the fields used in the selection will speed up corresponding accesses. The secondary index is a separate, small table that contains the index fields and a reference to the relevant data records for each data record in the actual database table. If the fields in the selection match the fields in the secondary index, or at least left-aligned and gap-free, the database searches within the secondary index and then reads the corresponding data records through the reference. Create a secondary index in display mode for the relevant transparent table in the RBAP dictionary using the Indexes push button. When you activate the index, the secondary index is created in the database. For data retrieval, the system allocates a major proportion of runtime to transfer the data from the database server to the application server. If the data is frequently read but seldom changed, you can reduce runtime by buffering the data on the application server. If an RBAR program reads a buffered table, the database interface first tries to get the required data from the SAP table buffer. Reading data from the SAP buffer table speeds up access by a factor of between 10 and 100 compared to reading data from the database. The precise increase in speed depends on the structure of the table and on the exact system configurations. If the required data is not yet in the SAP table buffer, the database is accessed and the read data is then transferred from the database interface and also stored in the SAP table buffer.
There is often a requirement to read data from various tables and display it on one table. In general, the technique with the best performance for this task is a table join. You will read and output records from the database table SPFLI. For each record, the full names of each respective airline, which are stored in SCAR, are to be output as well. The figure shows the logical creation of the corresponding table join from which you can select all of the required data using the select statement.
Specify the following details when defining a table join. Join tables. Which database tables should be accessed and joined? Join conditions. What are the conditions for summarizing the corresponding records in the tables to be merged in a table join? Join columns. Which columns from the selected tables should be made available in the table join? The different ways for implementing a table join are as follows. In the ABAP dictionary, create a database view that corresponds to a table join and select from it in your program. For detailed information, refer to the online documentation for the ABAP workbench in the ABAP dictionary section. In your program, select from the defined join options or ABAP join. At runtime, the system dynamically generates an appropriate database query in the database interface. For more information, see the keyword documentation for the from clause of the select statement. The table join view shows the relevant database tables without data redundancy. When a selection is made in the joined table, the data is read from the corresponding database table. You can join more than 2 tables in a table join.
In addition to the select statement, OpenSQL contains the update, insert, delete, and modify statements. However, it is important to understand the SAP transaction concept associated with these database change accesses to avoid causing data inconsistencies.
You must protect critical data and parts of the functional scope of the SAP system from unauthorized access. You implement authorization checks in your program so that each user may only access areas for which he or she is authorized.
You can define authorization objects within object classes. When defining an authorization object, specify the appropriate fields without values. Create an actual authorization by assigning values to these fields. This authorization can be integrated into the required user master record through an authorization profile. Several different authorizations for integration into different user master records can be created for an authorization object. At runtime, use the authority check statement to check whether the user has the authorization required to execute the function being called in the user master record. Depending on the check result or SY sub RC, continue the program accordingly as follows. SY sub RC equals 0. User has the required authorization to perform the function, for example, select, and to continue with the program. SY sub RC greater than or less than 0. User does not have sufficient authorization and an error or warning message is displayed. Similar to the technique described, you have the possibility of controlling access to the entire program and transactions using authorizations. However, consider such checks as additions to and not substitutions for the explicit authorization check by the developer. Under normal circumstances, the definition of authorization objects is part of data modeling and the creation of database tables. In this course, you will access an existing data model so that you can use authorization object S_car ID in this data model. Implementing the authorization concept is one of the tasks of the developer who programs access to database tables. The subsequent steps, such as defining the authorizations and profiles and designing the user master records, are tasks of the administrator.
Before you can implement the required authorization check in your program, determine the structure or the fields of the respective authorization concept. An object usually consists of the ACTVT or activity field and one other field, which specifies the data type to be protected, that is, material number, airline, and so on. The values of these authorization fields specify what each user is authorized to do. You can display an authorization object directly in the ABAP workbench, for example, by using the Other Object push button or the Other tab page. You can also use transaction SU21. Here, you will get an overview of all of the authorization objects created in the system. The figure shows how to implement an authorization check.
In this example, the user authorization for access to the S_care ID is checked. Field care ID or airline contains the airline entered by the user, and field ACTVT or activity contains the value 03 on display. After the authority check statement, check return code SY sub RC and monitor further processing of your program accordingly.
To avoid spelling errors in object and field names, generate the authority check statement in your source code by using the pattern push button. Then, maintain the field values and implement the evaluation of SY sub RC.